All right, class, hello. This is a special video for you guys. This is the first time I've actually required a video to be watched as homework. So this is a homework assignment. Later on in this video, I will be saying a random fact about something, and then I will ask you on Tuesday on our next class as proof that you have watched this. So you guys will text me privately in the chat next week. So please make sure to watch the whole thing. This is the Super Bowl of our whole unit, absolute value inequalities. You guys remember absolute value from last chapter? We were doing absolute value equations. Remember, if it's positive, it has two results. You set up two equations, you get two answers. Hopefully that all rings a bell. You guys were doing very well with absolute value equations. Now we have an absolute value inequality. Notice I have kind of a key on the side here, and I will be providing this for you as well. If there's something I'd either want you to memorize or know, this is kind of the cheat sheet of how we're going to solve absolute value inequalities, okay? So first off, whenever you see the absolute value all by itself and isolated, right now this x minus 5 absolute value, that's isolated, there's nothing else going on, take a notice at the inequality sign. If it is less than or equal to, it is always going to end up being an and statement. So remember our conjunction statement, our and statements from today in previous lessons. The graph is going to be in the middle. The x is going to be in the middle if we have a less than or greater to. Notice in our absolute value equation right here, we have a greater than or equal to sign. If we have a greater than or equal to, we're always going to have a disjunction or an or statement. So the graphs are going to be going out. I'm going to show you guys how to do this, okay? There's a couple ways and a couple distinct ways to set this up. Okay, here we go. X minus 5 greater than or equal to 2. Just like in our equations, we notice that since this is isolated and that's positive, we are going to have two solutions. Okay, so here we go. If there's nothing else going on the outside, notice there's not any adding or subtracting. There's not anything in front of the absolute value. This is isolated, so we're good. When that's the case, we set up two equations. Okay, just like absolute value equations, we're going to set up two inequalities now. Here's what we do. All right. Make sure that didn't mess anything up. Our first way of solving is solving as normal. So here we go. X minus 5 is greater than or equal to 2. Just like we did in absolute value equations, we set up the first equation just as is. All right. We set up everything as is. We just ignore the absolute value, and now we solve. It becomes just like a normal or statement inequality. If we want to get that x by itself, we add 5. I have x is greater than or equal to 7. And just like that, I have my first inequality, okay? And now I'm going to just graph that section. We know if that's a greater than or equal to, we're going to have an or statement. So we know one graph is going to be going either to the left or to the right. It's not going to be combined in the middle. X is greater than or equal to 7. I'm just going to put, I'm going to leave that right there for now. I'm going to put my tally marks, see what I have. Okay, this is it. If you can get how we get our second equation, this will be totally fine, okay? First off, I'm going to ignore the absolute value, x minus 5. Now remember a month ago when we were doing absolute value equations, do you guys remember what happened when we're finding our second answer? Ding, 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 we make that negative, okay? So we're gonna make it negative, but please do not forget, when you're finding out the second solution and you're making that negative, we have to flip the sign. So in a way, it's kind of like dividing by a negative, all right? So we are gonna flip the sign now. Even though we flipped it, originally it's greater than, so it's still an or statement, but we flipped it. This is just a strategy of finding the second solution, just like we did on absolute value equations. Now this is a strategy of how we're going to find the second solution for absolute value inequalities. And now we just solve again. We add 5, x, I'm going to cross that off, is less than or equal to, negative 2 plus 5 is 3. There we have our or statements solution. x is greater than or equal to 7, or x is less than or equal to 3. Let's graph. If this is 3, x is less than or equal to 3. I'm going to be using this one first, okay? I'm going to be using this equation first. X is less than or equal to 3. It's going to be a filled-in circle, graph going to the left. 4, 5, 6, 7. Here is 7. I'm going to fill in circle because it is an equal to sign, just like it was up there. X is greater than, so greater than is going to the right. And we have just solved our first absolute value inequality. The biggest thing, there's 3 things you need to know. 1, after it's isolated, after the absolute value is by itself, do we have a conjunction or a disjunction? Do we have an and statement or an or statement? That's check number 1. Number 2 is set up both of our equations. And the last but not least you really need to know is that whenever we find that second solution, if we make that negative like we were doing before, the sign has to flip for an accurate answer. Okay. Now, what if we have a and statement or a conjunction statement? Here we go. Okay, everyone, here is the answer to the secret question that I will ask you on Tuesday as proof of watching this video. What dog did I used to have? That was a greyhound. Answer. Okay. Now, what if we have a and statement or a conjunction statement? Here we go. Okay, the absolute value is all by itself. It is isolated. There's nothing being multiplied or nothing being added or subtracted. So now I can immediately look, that's positive, so we're gonna have a solution. That's a less than or equal to sign, less than or equal to sign. We have a conjunction, that is our and statement, okay? So we're gonna set up our 2 equations. Okay, first equation that I'm gonna set up, and on and statements, I want you guys to do this. Use the right, when you do a T diagram, I really want you to do a T diagram because then you can do each equation. Do the, like as if nothing changes on the right side. So x, and of course I'm running out of ink here, x plus 6 is less than or equal to 11. On and statements, where nothing else changes, if we're just solving the first solution as normal, put it on the right side because there's a strategy for that later. All right, so my x is not by itself yet. I'm gonna subtract 6. Subtract 6. Now I have x is less than or equal to 11 minus 6 is 5. Okay. All right, now here we go. Second solution on my and statement, I'm going to put it over here. My x plus 6 hasn't changed. That 11, instead of being positive, recall, to find that second solution, we're going to make it negative. But negative, that's a red flag. If we make that second solution negative as part of finding the answer, we have to flip that sign, okay? It's still originally a conjunction statement, an and statement, right? But part of the strategy of finding that second solution, making that negative, flipping the sign, okay? Now, let's get x by itself. I'm gonna subtract 6. Subtract 6. Here we have x is, let's see, those cross out, greater than or equal to negative 11 minus 6 is negative 17, okay? Now, the reason why, this is an and statement. So it's an and statement, so we know that we have to have a compound inequality with x in the middle, okay? And this is why I wanted you guys to have the strategy of do the normal first equation on the right side, and then the second equation that where we make it negative on the left. Because then we just take that number right there, negative 17, which is obviously less than 5. 5's our other outlier over here. And it's negative 17 less than or equal to x less than or equal to 5. Remember recalling and statements. If the lesser number's on the left, we're always dealing with less than signs. And it makes sense because look, this right here, the mouth is opening up towards the x. The mouth is still opening up towards the x. We just kind of switched it, right? That 17, we kind of just flipped everything and created our compound inequality, our and compound inequality. Okay, now graphing, and then we are done. Negative 17 over here. It's a closed circle. Here's 5 over here. Once again, another closed circle because we have our equal to sign. And we know since x is in the middle, it's an and statement. Our graph is in the middle of our conjunction statement. Conjunction and and mean the same thing. Disjunction and or mean the same thing. There's our graph, and theirs would be 0. Okay. There's an example of an and statement and an or statement, what we are going to be doing on Tuesday.